So, Bill's going to be presenting for our first in-person meeting, Mars Rovers, class of 2021. NASA's exploration of Mars continued in 2021 with the arrival of NASA's Perseverance rover carrying the Ingenuity helicopter. What's more, an orbiter and a rover journeyed from China, a new player in interplanetary space. Perseverance's mission began a plan that years from now aims to bring samples of rock and soil from the Martian surface to laboratories on Earth. Bill Higgins examines the engineering and science of these remarkable robots. Bill Higgins, a volunteer speaker in NASA's Solar System Ambassador Program, speaks and writes about spaceflight, astronomy, and other topics in science and technology. He works as a radiation safety physicist at Fermilab, where he is involved in the transport of high-energy particle beams. He joined the Naperville Astronomical Association in 1989. Please welcome Bill
Higgins. I'm honored to be invited to give the first talk after the hiatus. It's an exciting year on Mars, so I chose to talk about the class of 2021 in Mars rovers, and since I have 3 vehicles to talk about tonight, then I'll probably won't give as much detail as you might like for any one of them, but I'll try to breeze through them all once over lightly. I am a volunteer in NASA's Solar System Ambassadors Program, which is simply a way where volunteers offer to bring some kind of information to the public about NASA missions and science and technology. And I've been doing that for over 20 years now. Okay, this is my laser. This is my next button. There are, we are in the middle of exploring Mars, we the human race, and at the moment, from Olaf Frone, he keeps track of these things and makes a lovely graphic every now and then of missions in the solar system. We learned that there are 8 orbiters currently circling Mars, and there are 4 working rovers on the planet, and there is 1 lander, the U.S. InSight. And a whole bunch of countries have become involved. It isn't just superpowers anymore. The European Space Agency and China, as we'll see, have spacecraft, and India and the United Arab Emirates have, in recent years, joined the club of the Interplanetary Exploration Club. Japan doesn't have anything here at Mars at the moment, but they're very busy at Venus and asteroids. And the good old United States. The landers are our good old Curiosity from 2012, which is still going, and the InSight, as I mentioned, which is a geophysics mission, and tonight we'll be talking about Perseverance and Ingenuity and the Zhurong, the Chinese rover. This is where spacecraft have landed on Mars, and the ones that get white letters in their names were successes, and there's a number that failed too, and so their grave sites are also marked here. But if you're fond of Mars, maybe you know that most of the northern hemisphere has rather low elevation and is kind of smooth, and most of the southern hemisphere is much rougher and more rugged and has more craters and such. And Perseverance has landed on kind of the border between the north and the south, right here. At a place called Jezero Crater, and Zhurong has landed in the vast area called Utopia Planitia right here. It's it looks like it's kind of a neighbor of Viking 2, the old Viking 2 lander, and it is, but they're like 1,700 kilometers apart because it's a big planet, and Utopia, Planitia is a big place. And there's a nice graphic decorating the U.S. rover showing a kind of evolutionary chain of American Mars rovers. So Sojourner and Spirit and Opportunity and Curiosity and this year's Perseverance and a little Ingenuity helicopter. The Perseverance is the big show as far as the American side is concerned, and it is a whole lot like the familiar Curiosity rover, which landed in 2012 and which I imagine you know a good bit about. That it has made some improvements over the Curiosity design, but it's still a buggy like Curiosity, powered in the same way by radionuclides and with a similar wheel system, and it has a mechanical arm and so forth. But there are tweaks in it, and there are some radical new capabilities, and some things that Curiosity had that Perseverance doesn't have. So they improved the wheels because Curiosity had some problems with wear on its wheels. They've worked very hard, the software department, on getting robots that are better at driving themselves to targets you direct them to, and figuring out the best path to go there. The drill can go deeper, and it is a drill that can make cores. So something like sort of a little cylinder, like a piece of chalk or so, about 5 centimeters long, and it will pull cores here and there out of rocks on Mars and stash them in sample tubes. And this is not just a mission for today. The main goal of Perseverance is to obtain a decent collection of samples for another mission someday to come to Mars and pick them up and put them on a rocket and launch them into Mars orbit and send them back to Earth. So this is a big deal, and it's all that stuff isn't really funded much, but we've begun to make big plans in multiple countries, and the main camera is much better, and it can do zooming as well as looking at the landscape. This thing was launched about a year ago on the 30th of July, and it landed on the 18th of February. I chose this picture as a pretty good view. This is a slide about cameras, but it gives you a pretty good view of what the rover looks like. The first thing you notice, other than a 6-wheel vehicle, is that it has a tall mast looking kind of like a head right here, and it has an arm about 2 meters long, and on the end of the arm is a grotesquely large collection of many different gadgets and so there's like 2 different cameras on the end of the arm, and 4 cameras on the front looking for possible hazards along the ground to navigate with, and there's more in the back, and there's a whole bunch of cameras on top, some of which are mainly for doing science, and some of which are more helpful in navigating and driving the lander. And we're up to 23 now. So this is like the cup holder race in the minivan, among the minivan manufacturers. The next model will probably have even more cameras. Oh, and there's a few cameras on the vehicle that the Perseverance rode to get down to the surface of Mars. It like Curiosity was landed by the crazy combination of heat shields and parachutes and a rocket that hovers near the ground called a sky crane, and which lowers our vehicle down on some cables and flies away after the rover touches the ground. One way to think about this mission is to say, well, I know something about Curiosity. I've seen pictures and watched the news. So how is it different from Curiosity if it is so similar? As I said, it still has the sky crane landing system, and it has cameras on the mast, but they're somewhat better cameras and a few more cameras. It has a gadget to use a laser to do spectroscopy on rocks. It identifies a rock it would like to sample, a soil or rock or anything in the environment. It fires a very energetic laser pulse and vaporizes a little hole in Mars. And it vaporizes it. It doesn't just vaporize it; it makes a plasma. The plasma gives off light. So the light there's a serious telescope and spectroscopic equipment built into this mast, and from that flash of light, we can learn a lot about the materials stuff that previously wasn't a hole, but now a hole was made of. So there's an even better death ray on Perseverance than Curiosity had. Once again, there's a weather station that is many instruments to collectively figure out the wind speed and temperature and pressures and so forth to understand the Martian atmosphere better. And like Curiosity, there is a camera in fact, there are two cameras at the end of the arm that serve as they look at the microscopic scale. It can see a rock or some soil close up and do what a geologist would do with a magnifier. What is new on Perseverance? As I said, this drill doesn't simply grind rocks to a powder and feed the powder to a bunch of chemical analysis instruments. It can get cores. Now it has instruments that can examine the chemistry of a rock surface as well on the end of the arm, but the coring drill is the start of the process of caching samples for pickup in future Mars robots. So it has a system of metal tubes that it's supposed to put these cores into and leave them lying around on Mars. There's an experiment called MOXIE, which is takes the Martian atmosphere and makes oxygen out of it, just a few grams at a time. But it's a chemical engineering experiment to see if all of these years people have been saying, if you wanted to settle Mars, you could get oxygen out of the CO2 in the Martian atmosphere. You'd use this kind of process and so forth. Well, this is an experiment where they actually try to see whether that works on Mars and how. I mean, I don't think anybody doubted it would work, but how well does it work, and what do you learn when you actually try to fly a real gadget to do this? So if you believe that someday we will provide rockets on Mars with oxygen for their engines in order to make a return, or if you believe that we'd like to have people living on Mars or vehicles running around on Mars and they'll need oxidizer, and we could make the oxidizer with chemical engineering, this is the dawn of that era, of that moment. It's one baby step along the way to domed Mars cities or whatever your imagination gives you. There is an instrument on the end of the arm called Pixel, which can make a narrow beam of X-rays and get information from the X-ray fluorescence spectrum of whatever the sample is, and also and to sort of make an image like a picture of the glow from that's stimulated by the X-rays, but pictures in different bands of light that could be coming out from that. So it's an imaging spectrometer, sort of, but illuminated with an X-ray instead of the flashlight. So you can learn interesting chemistry from that you can't get from other kinds of instruments we've flown to Mars. The Norwegians have contributed a ground-penetrating radar to understand something of the structure below the surface of Mars. And another instrument on the end of the arm does Raman spectroscopy, which involves ultraviolet laser and measuring fluorescence from that. And I actually wrote a paper when I was in college on Raman spectroscopy, and I've forgotten everything. Don't ask me about it because I've forgotten how it works. I would have to hit Wikipedia to tell you and be reminded. But here is a slide. I don't care for it because the print is really a little too small, but it does show the layout of the instruments, especially the instruments you can't see very well in the external views we were just looking at. So the arm is kind of folded up here. So we have the pixel sensor at the end of the arm in that big clump of equipment, and also the Sherlock experiment, which is the Raman spectroscopy experiment. There are various calibration targets and such around. Here's the mast with the laser system called SuperCam, and which it has a high-resolution camera and a really nice telescope and fiber optics that go down into the bowels of this thing to feed spectrographic information. And there's a zoomable high-resolution camera on the mast, and MEDA is the name of the various of the weather system. So you can see a lot of sensors marked MEDA around here. MOXIE is somewhere in the interior of the chassis, and RIMFAX, the ground penetrating radar, is here with some electronics over there. But this at least gives you kind of a sense of that, oh, there's a lot of different science going on, and it's distributed all around the rover. By the way, I think if you probably know this, but if you think of a question, I would prefer that you ask it as we go along when you think of it, rather than waiting to the end. So let me know if you're wondering something. Another thing where I could just give you a brief glimpse of the complexity is the sampling and caching system. Once again, here's the arm. This picture shows a lot of the mechanical parts of it and such, and the turret that holds the instruments, and the coring drill, and something that abrades a smooth surface on a rock, and something that blows a puff of gas to blow the dust away so you can get a clean look, and the instruments can get a clean look. All that stuff is out here, but the coring drill is able to put the core. It obtains into a sample tube, and then some combination of the turret and this other fancy complicated machinery, like a carousel that can hold a few sample tubes and revolves around. So out here the arm can access it, and down here it can be accessed by machines that take these things out and put them away. Underneath the rover, if you crawled underneath the rover and looked up, you would see this open area. You get to see the sample tubes, which are essentially empty now, but which they hope to fill up the first one this week. And there are 42 total sample tubes, and a system of arms and such to pass them around, and then seal them suitably after there's a sample in them and so forth. Here's a few details, but this is what a sample tube looks like with maybe it's the size of a cigar tube. Does anyone remember cigar tubes? Something like that. And the core's like about this long and about 1 centimeter in diameter. There are some essentially, well, tubes called witness tubes, which are not going to be carrying any sample, but which will be exposed to the same conditions as the drilling from, or as the rest of the samples from time to time, so that you'll open this witness tube on such and such day in such and such place on Mars, and it will be experiencing an environment like the environment that we've collected everything in. So that will help sort out what is signal and what is noise in the Martian geochemistry once we get these things back to Earth. The reason for all of this, of course, is that you can work miracles and spend tens, if not hundreds of millions developing miraculously small and low power and smart instruments to operate on Mars aboard a spacecraft or a rover or a helicopter or whatever. But those instruments are never going to be as good as the big, heavy, power-hungry instruments you have at home in the best laboratories on Earth. There's a whole industry of people who study meteorites, right? Like, they have samples from outer space and they can do chemistry on them. And many times we've had speakers who've talked about that kind of thing at the club, and it's just amazing what they can do with, not with a gram of material, but with a milligram or even a microgram of material. They can tell you a whole lot about what this meteor experienced back when it was in space. Well, that would be a lovely thing to be able to do with a piece of Mars. And especially if you know exactly where on Mars that rock came from. And that is why everybody's been lusting after sample return missions since ever since I can remember, since the days of Viking anyway. Sample return from Mars seemed to be the thing to go for. But it was clearly going to be expensive and time-consuming, and maybe be such a large project that it would take multiple countries. Well, that's the path that we are now embarked on. Meanwhile, we've got a rover, we've got some instruments on it. We can learn a lot in situ on Mars about an environment, and then if you have a very capable rover on Mars that you're sending to Mars, then you have to have a lot of arguments with other scientists about where's the best place to land it. Because really, we need 20 rovers on Mars to understand Mars, or maybe 100 rovers on Mars, but we only get one every few years. So figure out what the hottest questions are, and figure out what likely places that you understand from all these pictures from orbit and the information you have from previous rovers. What's the likeliest place that's where a rover will be able to find the most questions? This year, the answer to that, or the consensus on that, turned out to be a place called Jezero Crater. Jezero Crater is a pretty fair-sized crater which once had flowing water. More than that, there's clearly a dry riverbed that leads into it. So once upon a time, a river brought stuff from along the river to Jezero. Once upon a time, Jezero held a lake, and that river flowed pretty fast. And as rivers do, when it got out into this lake in this crater, the flow slowed down, and it dumped the stuff it was carrying, and it made a delta. So a river, a lake, and a delta are all really interesting places for geologists. And if there was ever either life in the past on Mars, let's say microbial life, or some kind of conditions that might possibly have led to life, the history of the physics and chemistry of that environment, it can be read pretty well in these deposits, possibly carried from far away. So Jezero is supposed to have the best chances of signs of past life. Here's the region where in the weeks to come, Perseverance will pick up its first sample. There's some light-colored rocks that look like kind of fractured. They're calling them paving stones. You know, kind of a fractured floor of a different color from much of the rest of the place. There are also rock fragments that don't look as pale, that are scattered around here and might have a different origin or a different history. Here's Jezero crater. We only see a portion of the circle of the crater here, so here's the rim wall. But here's the river bed I was talking about, entering the crater and slowing down and dropping what it's carrying to form a delta. And somebody tossed a rock in from outer space long after this delta was made and made a crater. And here's another little crater. So there's some history of cratering in here since the formation of Jezero. So that helps you understand something about the dating of this. This is all nice stuff to explore. A flat lake bed and many layers of deposits in the walls of this delta feature. There are sand dunes and such. All great fun if you wish to explore a barren planet. Here is a self-portrait that one of the cameras on the arm of Perseverance has taken. And as you probably know, Perseverance carried a little helicopter with it. And in this picture, it's driven away from the helicopter, it's looking back at Ingenuity right here. And I'll get to Ingenuity in a little while. But that's the Perseverance story. The Mars sample return mission is still kind of on the drawing board, still notional. It's firmed up considerably from the vague paper speculations I always used to see at conferences in the 80s and the 90s and the aughts. So I think people understand how to do this pretty well. It's looking like the European Space Agency is ready to cooperate and contribute some of the parts of this mission. So one day, possibly, let's say 2026, spacecraft will be launched to Mars, and that spacecraft will land and deploy a small rover, probably built by the European Space Agency, and that rover will run around and go to wherever Perseverance has left its sample tubes. It might be a pile. It's probably not all the sample tubes in the same place. Possibly Perseverance will deposit a cache, I don't know, 15 or 20 of them or something, and then go on to continue its program of traveling around Jezero and collecting more samples. But, if, God forbid, Perseverance fails after a few years of this, there'll be an initial set of samples that'll still at least be available for the follow-up rover to get. And this rover won't do much science. It'll just go get those tubes and carry them back to the landing vehicle. And hidden inside the landing vehicle will be a capsule on top of a solid fuel rocket. Maybe I don't know much about the rocket, but a couple stages possibly. So the tubes will go into the capsule will be on the rocket, and the rocket will be elevated and blast off from Mars. And it isn't huge rocket that can go all the way back to Earth. It is a rocket just big enough to go into orbit around Mars, because our friends at the European Space Agency are expected to also build an orbiter that will circle Mars for some years and get ready for this this small rocket to show up and fly to a rendezvous with it, and then take the precious sample out of the capsule, or I think maybe take the whole capsule and then shove that into an even larger capsule, taking care not to contaminate anything with Earth stuff or any of the Mars stuff, any of Earth stuff with Mars stuff, and making a sealed capsule that will then fly back to or depart from the orbiter, fly back to Earth, and parachute to a landing probably around 2031 on this timetable. This stuff could slip by a year or two, as depending on funding and depending on when things actually get built, and depending on, of course, the launch window from Earth to Mars and the other launch window from Mars to Earth. But this is closer than it's ever been to reality in my whole life. So even though this still seems kind of far off, I'm pretty excited for it. And speaking of excitement, we have a new interplanetary power. The nation of China has had great success with its lunar exploration, and they've flown orbiters around the moon, and then they've landed on the moon, and they've operated one rover on the front side and followed up with another rover on the back side and a communications satellite. And last year they grabbed a sample of the moon, put it in a rocket, and brought it back to Earth. So since, I don't know, 1975 or 1976, there's been 9 places that have been sampled, where samples have been brought back from Earth. Now, after a long, long time, we have a 10th place that's been sampled. So all of that suggests, gee whiz, China has some pretty competent space engineers, and they kind of went for broke and decided to go all the way to Mars with their first orbiter. And by gosh, their first orbiter carried their first Mars rover, and it worked. So they launched last year in the 2020 window when everybody else was launching. They entered Mars orbit on the 10th of February, about a week before Perseverance landed, and then their orbiter Tianwen-1. By the way, I'm mangling my Chinese pronunciation. I'm sorry. This is something I could improve on, but Tianwen-1, as I call it, is surveyed Mars and has particularly scouted out a good landing place for the lander and rover. And on the 14th of May, the whole assembly landed, and the lander has a platform or a ramp that the rover rolled down, and the rover was called Zhurong, named after the short phrase is fire god, but a mythological supernatural figure who is identified with fire and with the planet Mars, which after all is orange like fire. It's bigger, it's heavier than the lunar rovers. It's 240 kilograms. It's solar powered. The nominal mission is 90 sols, 90 Martian days, and we're probably about halfway through that at this point. It has some of the things that other rovers have had. It has cameras, as you'd expect. It has weather measuring equipment. It has a laser breakdown spectroscopy gadget like the American rovers Curiosity and Perseverance that I was just talking about, and they have a ground penetrating radar. So this thing is capable of quite a bit of science. I can't tell you that I know much of the science it's done, but they have been releasing nice pictures. And here is something that I already talked about, but it also comes with a free picture of a camera looking up and watching the parachute open. So after checking out that everything was working, the rover rolled off its platform and met the surface on the 22nd of May.
Hey, Bill,
Yeah,
does their parachute have something encoded in
not as far as I know, but then I can't read Chinese parachutes. Yeah, there's a secret message encoded in the color pattern on the American parachutes for Perseverance, and the public was sort of invited to figure it out, and the public did figure it out. It encodes the JPL motto, the Jet Propulsion Laboratory, built Perseverance. I don't know. Wait a minute. Okay, you tell me. Does that parachute say anything? It's a reasonable question, but I haven't tried to puzzle it out.
Maybe China.
Perhaps. This is spectacular. Here's a rover front camera looking at the planet ahead, with a couple of its antennas sticking out the front like horns. And here is a rear-looking camera. Happiness is the landing platform in your rearview mirror, right? And these pictures come to us from China's National Space Administration. The first color picture that the rover sent back was an image taken from its mast, looking backwards towards its high-gain antenna, and we see its solar panels, and details of the Martian surface at Utopia. This is really cool. They made a little camera that the rover could drop, and which would take a picture of the rover from outside the rover, and also the lander. So this is great. In fact, combining enough pictures from this, you can get a little movie of the rover making its maneuvers, which I didn't bring, but way to go, China. And the triumph of the Chinese way of life is indicated by the national flag right here. Another cool thing that you don't have to be a scientist to understand is the back shell and the parachute of the platform that the spacecraft the rover rode down on was really not all that far away, and they decided to drive there, so it got to see a piece of its own vehicle on the Martian landscape, and that's kind of fun. So this thing is going pretty well for people operating a first-time rover. Zhurong is moving south from its landing site here, and as of the 21st of July, it had gotten down here. About a week later, we have information that it had rolled even more than 700 meters. Pausing to take various measurements along the way. It's a landscape that we can see a lot of crater. I can't tell you much geologically about this landscape, but in the course of time, I'm sure we'll learn a lot of science from that. So it's really nice to have another country in the club and another team of creative people thinking about how to make spacecraft to explore, because exploring a whole planet is a very big job, and it takes more than 2 or 3 rovers to get it done. We're making progress, folks. There's a new way to make progress. Speaking of wacky creative engineers, there are American engineers who have long wanted to fly something on Mars, like fly in its atmosphere. And this dream achieved fruition this year because not only did they design an exotic helicopter that could operate on Mars, but they also persuaded NASA that to send it along with the Perseverance rover. So Ingenuity is this gives you a pretty good idea how big it is. Its fuselage is bigger than one of those small Kleenex boxes, but smaller than one of those big Kleenex boxes. It's got two rotor blades, about 4 feet diameter. We'll see a diagram with all the parts in another slide. But it has a total mass of 1.8 kilograms, so it is not very much of a vehicle. But inside there are enough batteries to run an electric motor and fly a coaxial bladed helicopter. I guess I should say that there are two rotors, one here and one here, and that they turn in opposite directions. It doesn't have much of an instrument load. It has two cameras, a black and white camera that's primarily used to image the landscape. A computer inside grinds on the images and tries to figure out where it is and how fast it's moving and all that kind of stuff by comparing images, which is kind of like how you drive, I think, but not very much like a lot of other guidance systems. And it also has a laser altimeter, LiDAR, if you like, when it's fairly close to the ground at takeoff and landing, then that is helpful in getting it down safely. It has a radio just big enough for short-range communications, so it can talk to the rover as long as the rover is sufficiently close, but it cannot talk to Earth. But the rover has plenty of capability to talk. Most of the time, Perseverance and Curiosity actually talk to radios that are in satellites going overhead. I always love to point this out. We have communications satellites orbiting Mars, and multiple countries have launched them so that they can, if one of the old orbiting spacecraft goes dead, we still have a few others from multiple countries that could help out by doing communication relay, and this makes it much easier because for more frequent communication with rovers on the ground or landers on the ground. Here's a diagram, and I probably described most of the features, but come on, yes, the solar panel that charges it up is on top of the rotors here. And there's some antenna and radio stuff also at the top here. And most of the electronics and batteries are in an insulated Kleenex box. And there are landing legs that have unfolded, and 4 legs that can land in a variety of terrains. And fancy algorithms for flight control, because this is the age of software and such. This actually has, being a more recent, design that was put together on a pretty small budget, and it is a technology demonstration, not a science mission. So they are allowed to take risks on things that might work, and less expensive off-the-shelf equipment that they didn't have to develop specially, and all in all, like, basically NASA was gambling that if it failed, it wouldn't be much of a loss to the main mission objectives of Perseverance. So that being the case, they were able to use a more recent computer in Ingenuity, and it's actually got way more computing power than Perseverance does, though it has fewer jobs to do. Ingenuity was folded up in a container underneath the belly of the rover. I have a tendency to say it piggybacked a ride on Perseverance, but it was really sort of piggy bellying a ride. When it's covered by a kind of oil pan looking thing called a debris shield, and we saw some of these pictures from Perseverance before Ingenuity deployed, and this is something that I put on Twitter when I was trying to figure out what parts I was looking at in the strange shapes in this picture. But the top rotor is this black thing here, and a similarly shaped black thing here is the bottom rotor, and they're both lined up, so they go kind of fore and aft along the rover. The landing legs are folded up, and they're right here. They're kind of like black spoons, right? And here in this box is the fuselage, and that unfolds and deploys into this, so it comes down like this from the rover, and the legs pop out. How do you operate a helicopter on Mars? Well, somebody had to try this out, figure out a plan, and then see if the plan worked. So first you take your rover and you drive it to someplace you think will be a good airstrip, a stretch of ground which is good for little fragile helicopters to land on. And if you've picked out that nice piece of ground, then you drop Ingenuity in something like in the picture we were just looking at, and okay, it's all by itself now, and it's running on its own batteries, and it's charging on its own solar panel, and Perseverance drives away. So it will be some distance away when the risky helicopter is about to operate, but close enough to be in radio range, right? The plan was to run 5 test flights. This thing doesn't have much endurance, 30 seconds, a minute in flight, a couple minutes. So but it just answers questions like, can you fly on Mars? Can you do your navigation systems work? If you want to try out a couple of different operational methods or whatever. And the first flight was on the 19th of April, and it went for 39 seconds, and all it did was spin up the rotors and take off vertically and do some turns in place and then come back down again, and it flew maybe, about 3 meters up. But it was the first time anybody flew an aeronautical vehicle on Mars, sort of. The first helicopter on Mars, that's for sure. Each flight got longer, more ambitious, covered more of a distance, and I think Flight 5 was actually the first flight that left and didn't come back and land at the same spot it took off from. Ingenuity was beginning to move around. After the 3rd flight, they said the technology goals that we said we were going to here to demonstrate are met. And after being very tight-lipped at all the press conferences about, well, wouldn't you like to fly this thing on ahead of Perseverance and scout it? Couldn't they be friends, roaming around Mars, kind of a buddy road trip? No. We're here to do a 5-flight flight test system lasting 1 month, and it'll be over then. But they were allowed to go into a so-called operational demonstration, and now they're doing more flights, and they are jumping ahead of Perseverance and all. So they're having more fun. Flight 9 was the last one I have data for, and it was aloft for 166 seconds and flew up to 5 meters per second, 11 miles per hour. When the black and white camera is looking down at the Martian landscape in order to figure out where it is, where it's been, where it's going, how fast it's moving, since they typically fly around noon, a downward-looking camera is going to see the shadow of Ingenuity, and that has become kind of a charming symbol of exploration. now. So flights 1 to 8 covered longer and longer distances as they went along, and as I said, they started to go on flights that didn't return to where they. When this is a plan for the 9th flight, and I think that they approximately followed this plan. It went over ground like sandy dune areas here, where which are not good places for rover wheels to operate. So the Ingenuity is kind of exploring beyond where the rover can go, and kind of skipping over something. If Perseverance wanted to get to this landing place, it would have to crawl around and try to avoid the sandy ground, right? And maybe have to climb up some other route than this cliff or escarpment, right? And a helicopter can just go there. So if they're proving their value, they're looking at places on Mars that aren't as easy to see from Perseverance, looking down at a series of ridges that the helicopter passed over. For instance, you can see the little foot of the helicopter here, and you can see the shadow down at the bottom of the picture. This is the color camera, which is better for doing science than the black and white camera. And there's also even an image where you could see the tracks that the rover has made in part of the ground that Ingenuity's flying over. So that's kind of what I know, and a fast look at 3 fascinating missions, and the only a bit of the science has begun to roll in, and I kind of skimmed over that in my talk. But Perseverance is starting its main mission of acquiring samples in the next week or 2. Ingenuity is probably going to finish its operation at the end of August, and Zhurong, I don't know much about its science plan, but it will obviously continue exploring Utopia Planitia for the foreseeable future. And I wish them all a great deal of luck. Thank you very much.
Is there any reason why it ends at August? Are the batteries depleted? Is there going to be potential for additional time as we've been getting out of these rovers?
I don't know the answer to that. You know, I've heard similar versions of that question at press conferences earlier in the mission, and I kind of alluded to questions like, well, what else are you going to do with the helicopter, right? But it's true that it takes people to operate it. It takes a certain amount of bandwidth for the rover has to be available, and it has to be in a place where communications can reach it, and so Ingenuity can't be allowed to distract the. There was only a limited amount of people time, you know, let's coordinate the helicopter and the rover time that they were willing to commit on this mission to add to the main goals that the very fancy Perseverance mission is supposed to be carrying out. So it's probably we gotta stop doing this sometime, and some management person decides it's the end of August. Now, also, the people who have now become experienced Mars helicopter operators, ought to get to work making a much nicer Mars helicopter loaded with instruments, right? That's a heavy payload and really would be good at either accompanying a rover or just exploring Mars on its own, or ferrying sample tubes from place to place, or what have you. And they now have experience. They are the senior people in the world of Martian helicopters, or indeed in extraterrestrial helicopters. And by the way, we have an approved helicopter mission for Titan, which is a lot. Dragonfly, some year, will fly to Titan and operate on Titan. A much friendlier place for aerodynamics, a much colder place for electronics and power. But so Dragonfly is very different from Ingenuity in a number of ways, but it's also, there are some problems that are similar, and people with extraterrestrial helicopter experience are probably valuable on that mission too. So we should get those people to work doing more helicopters, because we can think of more places to send more helicopters. That's my answer.
Bill, do we know what the communication range might be between Ingenuity and Perseverance? How far can
Let's
we go?
put it this way. That is known, I have forgotten. It's probably not 20 kilometers, okay? It's probably, it might be more than 1 kilometer. So I think it's probably in that range. There's, it's not a great deal of distance. What's really true is that the bandwidth gets worse as the signal gets weaker. So it might still be possible to drop down into a lower bandwidth mode and communicate with a very weak signal, but you don't really want to do that if you can help it. So that's probably a consideration. But I don't know I haven't read the manual to know what all the modes are and a simple answer to your question. Yeah.
For more capable helicopters, it's just a matter of larger rotors, faster, more RPM. What do you have to do to get something more big and capable?
Well, whatever it is, it would wind up being much more massive than 4 pounds. If you want to, you figure out what your mission is, right? And say, okay, what instruments can support this mission, and are they small enough and light enough to fit on a helicopter at all? And then start saying, okay, we can carry, our rocket can carry this many tons to Mars, right? So that means that our payload can be this much, and of that, the batteries have to be this percentage. We have this many kilograms available to be batteries, and batteries are the thing that dictate the length of your flight, the duration, and the margin you have for extra electricity and stuff, and they might degrade with time, so you might want to send more battery capacity now, but so that you have pretty good capacity a couple Mars years from now. And there's all that stuff goes into the design, but the solar panel does not come anywhere near supplying enough power to fly the thing. The solar power is there. The solar panel is there to spend a day of sunlight charging up the batteries and fly it in order to fly again. Well, and by the way, if you took a bigger solar panel, you could probably charge the batteries faster and fly more often. So there's a trade-off between the weight of your solar panel and the weight of your batteries. And that's the whole endurance question, and that sizes the rotors and the motors, and you get in arguments in your meetings over quad rotors versus 6 rotors, and it's a jolly time of trading off different possible helicopters. That's I don't know if that's actually a good answer to your question, but it's a process. Those are some of the considerations that would go into answering your question. Yeah.
For curiosity, what was the biggest, the big vision for that? Did we accomplish our biggest goals, and what are we looking at for Ingenuity?
Yeah. The second question first. Ingenuity doesn't do much science, right? Except for what you can learn from nice aerial photographs. The pictures the cameras can make, because it's just demonstrating the technology, and there really wasn't an instrument aboard. Okay, Curiosity is a heavy vehicle loaded with scientific instruments, and it's been operating for, I guess, about 9 years. So, and it's been way past the design life of its mission. Curiosity has done very well in it landed some distance from a mountain in the center of Gale Crater, and the mountain has. Long ago, Gale Crater was a lake, and the mountain is visibly many center entry layers which speak of the history of this crater. And Curiosity's been climbing that mountain on a winding path. It's been like a long time getting to the mountain, and then it's been climbing this mountain. And so it's gradually, it stops and studies the rocks with its many instruments, coordinated together on the different things they can tell you about today's sample or today's location. So it's, as I understand it, it's done great at that, and definitely it did its goals to give so much information about this particular crater over a couple of Earth years. And then it has gone way past that, just as Spirit and Opportunity did before. So in particular, the presence of water led to particular combinations of mineral deposits and particular conditions that inform our questions about, could Mars have been habitable? Could Mars have had an environment nice enough for long enough for life to arise? This spacecraft, or this rover, is no good at telling you whether there's life on Mars, but it answers a lot of questions about the geochemistry and the physics and chemistry and weather and so forth in that particular spot on Mars that we write in the book of Martian knowledge, and that book of Martian knowledge needs to get a lot thicker before we can be really sure about life on Mars.
That's about all the time we're going to have.
Okay.
So, thank you very much, Bill,
You're welcome.
for our inaugural.